Finally, in Module 2.2, we have an example of an application problem, a word problem with quadratic functions. What I like to do first with any word problem is read through the problem without trying to solve it, just read through it. Now let's do that here. A rocket is launched in the air. Its height in meters above sea level as a function of time in seconds is given by h of t equals negative 4.9 t squared plus 225 t plus 539. Find the maximum height the rocket attains. Looking at with any word problem, and we'll have lots of word problems this semester. With any word problem, it's okay to first read through the problem, and it's okay to not know the answer yet. But let's recognize some aspects of the problem, like the function that we're given. H of t equals negative 4.9 t squared plus 225 t plus 539. I recognize that, first of all, as a polynomial function, and more specifically as a quadratic function. When I see a quadratic function, I immediately think of that parabola, that U-shaped curve. And I see, if I'm trying to kind of picture that U-shaped curve of a rocket being launched through the air, I note that we've got a negative value for my leading coefficient. That means I'm going to have a downward opening parabola. A equals negative 4.9, that's a number less than 0. That means our parabola is going to open downward, and we're going to have a maximum. So we have a downward opening parabola. Imagine that rocket flying through the air and reaching some maximum height before it falls back to the ground. And they're asking us to find the maximum height the rocket attains. And having done this part of the analysis so far, I realize that finding the maximum height that the rocket attains is not going to be terribly difficult. It's not going to be doing anything beyond what we've already done, the type of work that we've already done in this module, because that maximum is just the vertex. So finding the maximum height the rocket attains translates into the math of finding the vertex of the parabola. Now that I see the math that needs to be done to answer the question, I can get down to it. Finding the vertex, h equals negative b over 2a. That's negative 225 over 2 times negative 4.9. Two negatives make a positive, and I can do the math, and especially with these more word problem type questions, it might take a calculator, and these squiggly equal signs mean approximate, so I rounded. I did the work in the calculator and I rounded it to 22.96 here. Then I'm going to plug that number back in to my function to find the height, to find the k value. That's negative 4.9 times 22.96 squared plus 225 times 22.96 plus 539. And again, calculator can help me do some of this math. And I get approximately 3,121.9. Now the input, let me use a different color here. The input value of 22.96, that is my value of t. T represents time in seconds. That means that the vertex occurs 22.96 seconds into the flight. And then my, change colors once again, my k value of 3121.9, that is the output. The output is the h value here, which is height in meters above sea level. So at a time of 22.96 seconds after the launch, the rocket will reach its maximum height of 3,121.9 meters above sea level. I have to make sure that I have the interpretation along with the calculations. Here is that interpretation. The rocket attains a maximum height of approximately 3,121.9 meters after 22.96 seconds.